All right, so rate laws, they're used to calculate the rate of reaction with a specific reactant concentration. So here's an example: N2O5 being decomposed or consumed into NO2 and O2 gas. The rate law for this reaction is written as rate equals K times the concentration of N2O5. So N2O5 is the reactant concentration, and K is our rate constant, So these are the two components that make up our rate law. It's written with respect to the rate constant and the reactant concentration. Now let's talk about the rate constant for a little bit. The rate constant, it's specific for a particular reaction at a particular temperature, right? So at different temperatures, the rate constant can change. It's independent of the reactant concentration, and it must be determined experimentally. It must be determined experimentally. So the rate law for a reaction is determined experimentally. So if we have a reaction with a single reactant, so let's say our single reactant is A and it forms some products, this is how we would write our rate. K times the concentration of A written to the m power. So m is the order of the reaction. It's the order of the reaction, and it can be determined using experimental data, right? It's not something that we determine from the balanced chemical equations. Reaction orders are usually positive integers, but they can also be fractions or negative numbers. You will actually be determining a reaction order in your kinetics experiments, where you'll see how it can actually be fractions, which we will most likely round to a whole number. So for a reaction that has more than one reactant, right? In this example, A plus B are reactants that form some products. Our rate law is written as rate equals K times the concentration of A written to the m power times the concentration of B written to the nth power. So M is our reaction order with respect to reactant A. N is the order with respect to reactant B. The overall order of the reaction is M plus N. It's the sum of all of our orders with respect to each reactant. That gives us the overall order. So what is the order? The order with respect to a reactant tells us the dependence of the reaction rate on the concentration of that particular reactant. The overall order gives an understanding of how all the reactants are contributing to the reaction rate. It also tells us or gives us information as to the units of the rate constant, because the rate constant, the units for the rate constant is not always the same. It will depend on the reaction, and you'll see that in some practice problems that you'll be doing in the discussion worksheet. So recap, order gives us it gives us information into the dependence of the reaction rate on the concentration of the reactants. If we're talking about an order with respect to that particular reactant, it tells us how the reaction rate is dependent upon that particular reactant, and the overall order tells us how all the reactants are contributing to the rate of reaction. So in the next video, we're going to look at an example of determine of how we can determine a rate law for a reaction given experimental data.